instruction types of Mips. So in this video, so let's look at the 3 different instruction types. Classes of Mips instruction. Before we go, so let's, here the classes, types. So I talk about types, classes, there are different categories. So we organize in different ways. First, let's look at the classes of Mips instructions. There are 4 broad classes of instructions. So let's look at these 4 classes first. So the first one, loads and stores, because they are very special. For Mips architecture, only this type can access memory, right? So that's the special things. Access memory, so that means read, write data. Read, write data. So that's the meaning. So we call memory access. For other instructions, we do not access data through memory locations. ALU operations, the second type. ALU operations. So that's the, in order to do some specific computation work, we need ALU operations. After that, another type, branches and jumps. Branches and jumps. Branches, so we call it conditional branches. So you need to have conditions, right? Conditional branches. Jumps, unconditional. You do not need any condition. You have to jump, right? You have to go there. No matter what happened outside, you have to jump to that particular location. So branches and jumps. Then the last, floating point operations. Here you can see the first 3 related to the integer operations. Integer operations. The last one, we do floating point operations. Yes, so here you can see from these classes, you can see when we do a computational task, most of our computation time is spent on integer operations. Only small portion is spent on floating point operations. So from here, you can also see that. All right. So next, we look at the types. So the categories, so we use different way to do category. Type, I-type. I, we know, refers to immediate field. Immediate. So we look at what is immediate field. Here, when I draw this diagram, it represents the full length of one instruction. One instruction, 32 bits, full length, and divided into 4 different fields. So let's look at each field. The first one we call opcode field. Operation, operator, opcode field, 6 bits. The first 6 bits is used for the opcode, the primary. Remember the last video, primary opcode. Secondary, the next type, we will see the secondary operations. How do we specify secondary? Second field, RT. RT, R means register. T, just a reference, some special reference. RT field, register location. Register location, 5 bits. So next 5 bits we use for RT field. Yeah. Next one, another 5 bits is for RS field. Now you can see the meaning of S and T. Yeah. So R, both register, refer to register field. Okay, but we need to separate. The first register field RS, yeah, here. Yeah. Although after the RT, yeah, but usually we say the first register field, the second register field, RS, RT. Okay, yeah. All right. The last field, immediate field. The constant, last 16 bits, constant, immediate field. So you can see for I-type instruction, we use these 4 fields to encode one I-type instruction. What kind of instructions can use I-type instruction? Yeah. Here, 3 cases. The first case, loads and stores. Displacement mode, loads, stores, displacement mode. So immediate field stores the displacement. Yeah. So look at first instruction, load, second instruction, store. Okay. So you can see in each one, we have displacement stored in the immediate field first. Second, base address, right? Base address stored in the RS field. The first register source operand. Yeah. Then the destination, this time. Yeah. Oh, when I talk about destination, yeah, here. Destination. Yeah. Because it is very easy to get confused when I talk about destination here. When I talk about destination, try to be careful. Okay? Try to be careful. There are 2 cases. The first, destination field. You have a field that is the destination. Yeah. So destination field. The second, destination but no field. Okay? The second one, you have a destination but no field. Yeah. Here, let me use these 2 examples to explain this difference. Yeah. Let's look at the first case. This time, destination R1, that is the destination field. Okay, R1, RT. Yeah. Why? Because the data you fetched from this location is stored in the R1 register location. That's the destination. You will store in that location. Yeah, destination, no problem. Yeah. But the store case is quite different. Okay, so what's the meaning of the store? All right, so you want to write your data, right? Yeah, this location is the write location. Data write to that. Yeah, that one is read, right? So this is a read location. Read operation. This is the write. With respect to memory, write. With respect to memory, read. Yeah, that's a difference. Yeah. All right. But write, what data you write, right? What data the data comes from R3 field. R3. Yeah. R3 corresponds to RT, right? This time R3, that's not destination field, right? Yeah. Not destination field. The first one is destination field, okay? Is destination field. Okay, the second one, not destination field, okay? Yeah. So what's that? Second source. Second source. The first source. First source. Okay? Second source. Okay? That's different. Yeah. All right. So then, the second one, there is no destination field, but there is a destination. Okay? Destination, this location corresponds to the destination. destination location. Okay, so we call the destination location, but there is no destination field. So that it's very easy to get confused. So here I try to, compare these related concepts. Now, because in my questions, you need to get to that kind of details. Sometimes I talk about destination field. Sometimes I talk about destination. That's quite different. Okay? Yeah. All right. So from these two examples, you can get this concept. All right. So next one. So let me erase this part. Yeah. The next one, conditional branches. Yeah. Here, conditional branches also use this I-type instructions. Yeah. So you can see I-type instruction, we can conditional branches. Yeah. What's that? BEQ R2, comma, target. We used before, yeah, BEQ, yeah, opcode, right? So this part opcode. Then R2, what's the R2? RS field, right? RS field. RT, no RT field. RT field, 0, nothing. Okay, 0, yeah, nothing. Okay, yeah, empty. Yeah. All right. Then target. Now the displacement, yeah, that displacement, right? So that constant number you need to add it to PC address, right? Address stored inside PC. Yeah. So we call it PC relative. Displacement. TC relative displacement. So this target. Yeah. So that's the conditional branch instruction. Okay. Yeah. Then next one, ALU, immediate instruction. Third case number 3, ALU. Yeah. I-type ALU operation. Immediate field is used as the constant. Immediate field is used as the constant. Okay. All right. So in this case, this constant is the first source operand. First source operand. This is the second source operand. Yeah. But from RS field. Yeah. So second source operand. All right. Yeah. This RT field, this is the destination field. See? Destination field. Okay. Yeah. All right. So that's the 3 cases for I-type instruction. Yeah. Our next type, another important type, we call the R-type instruction. Yeah. But this case, much easier. Only one case. We're only looking at the one case. All right. Here, the diagram like this, you can see how many fields do we have? 6 fields, right? 6 fields. Yeah, let's look at each one. The first one, opcode, 6 bits. Yeah. Second one, RD, destination. Yeah, register. R means register. D, destination. Okay, RD field, 5 bits. RT field, second source, 5 bits. Yeah. RS field, the first source, 5 bits. After that, there is a special field called SHANT. Amount. So what's the shift amount? Okay, we have left shift operation, right? Left shift operation by 2 bits. For example, right shift operation by 3 bits. Do we have that kind of operations? left shift, right shift. Okay, so this field specifies that situation. Left shift operation, right shift operation. When we do that, because shift operation, when we use that, it is very fast. When we have a situation like that, we should use the shift operation because it will be much faster than multiplication, division by 2, right? Power of 2, yeah. So that's why we use a special field for that situation. Okay, yeah, all right. The last field, function field. Function field, 6 bits. All right. So in this situation, now, because you may get confused, right? So the last field we used to specify the function, but the function, what's the difference between function and the operation, right? The same thing. In this education, in this R type, the opcode are all 6 zeros. Okay, so then we use the function field to store the operation types. So why is that? Because in this way we can separate I type and R type. How do we separate I type, R type, right? Look at the opcode. Look at the opcode. When opcode non-zero, that's I type, right? When opcode 0, that's R type. Yeah. Then we have chance to specify the function names. Yeah, in the last 6 bits. Yeah. That's the main difference. Okay. All right. Yeah. Then only one case corresponds to this R type instruction. That's the register A area instructions. Yeah. So you can see that's the example. Yeah. In this example, R1 we use RS field, R2 we use RT field, and the destination field RD field. Yeah. So that's simple. That's straightforward. Yeah. All right. So that's the R type instruction. Then the last one, J type instruction, jump. Yeah, remember jump, J type. Yeah. The jump, unconditional, you have to jump. You know, whatever happens, you have to jump immediately. So jump, J type. Only 2 fields. Yeah. Opcode, right? Yeah. So there are some, different small cases. We use opcode. Then jump. Where do you jump? So the next field we use to tell, the compiler how long to jump. The remaining 26 bits is used to tell the offset added to PC. The PC value, right? Yeah. Address of the next instruction is stored in the PC temporary register. Then you add that offset, that number of what? That number of instructions. Yeah, in our part E, I will talk about that detail. So when you jump, that number of instruction words. 1 means 1 instruction word. 2 means 2 instruction words, and so on. Okay, things like that. Yeah. Things like that. Yeah. So that's the case. Yeah. Jump. Yeah. But another case, jump the number of bytes. That's another case. Byte addressable, right? Yeah. So there are 2 possibilities. Jump the number of instruction words. Another, jump the number of bytes. It depends on the situation. Sometimes we use this way, sometimes we use that way. Yeah, that kind of detail. Yeah, we will see in our part E. Yeah. All right. Here, 2 cases. Yeah. The first case, jump and link. Yeah, because when you jump, the link, you need to come back, right? Come back, you need a link, come back. The first one, jump, you never need to come back. Okay? You jump, you go away, then, you know, just following the remaining of the instruction sequence. The second one, after you jump, you still need to come back at some point. Yeah, jump and a link. Yeah. Next case, trap and return from exception. Yeah, here, related to exception. When some exception occurs, then how to deal with it, right? Yeah. But this case, yeah, you just know it. We do not need to get there. Yeah. Actually, jump and link, we do not need to worry about. We just not need to know there is such thing. Yeah. But in our question, we only look at this case, jump case, unconditional jump case related to this instruction. That's enough. For J-type, we only look at the jump case. Yeah. Yeah. That's enough. Yeah. All right. So that's the